benzene, oil and flammable gas. In the vicinity of electronics, an explosive issue. Two tests show the causes of explosions and explosion protection. The first test, the causes of an explosion. A practical test. A plexiglass tube is filled with oxygen. When mixed with ignitable 5% propane gas, an explosive air gas mixture. The mixture-specific ignition curve is shown in a voltage current diagram. It shows the danger areas. The ignition energy caused by electrical sparks decides the existence of an explosion. If below the limiting curve, then no ignition of the gas occurs. If above, then an explosion takes place. Our test explains the situation better. Within the plexiglass tube, we have an explosive area. In the explosion-free area or safe area, we have a power supply at 24 volts and 2.5 ampere. The supply leads of the power supply are fed into the explosive area. In the worst case, what would happen with a short circuit? The energy-rich electrical spark ignites the air-gas mixture. In explosive environments, a dangerous fault with fatal implications. The second test. Appropriate protection measures prevent an explosion. Once more, the same situation. A plexiglass tube filled with an explosive air-gas mixture. Inside, the supply leads of the power supply, which is in the safe area. So that no spark is created that can lead to an explosion, the energy must be kept below the ignition energy of the mixture-specific limit ignition curve. This means that both the voltage and the current values in the explosive environment must be limited. For the realization, the protection class Intrinsic Safety offers a constructive solution. It principally consists of a resistor together with xenodiodes. It functions as follows. Firstly, a resistor limits the current, also in the case of dangerous short circuits. And secondly, a xenodiode limits the voltage in case of a fault. In measurement and control circuits, this is typically less than 30 volts. Both components limit the electrical energy. Correctly dimensioned, the spark energy lies below the ignition limit curve in the safe area, and the circuit is then intrinsically safe. Let's put the sample to the test. Our energy limiting circuit, also called secondary X protection, is installed in the safe area. At the input of the supply or the signal lines from the safe area, and at the output of the intrinsically safe circuit for the explosive environment. We test the worst case once more and short-circuit the leads. A spark is created, is however unable to ignite the explosive air-gas mixture. The ignition energy is too weak. The reverse test. The secondary X protection is removed. The spark that is now created ignites the air-gas mixture and causes an explosion. Prevent major malfunctions with innovative interfaces. Consider only 12 mm width requirement per channel. Modular and rail mountable, together with optimal expansion possibilities. Elegantly bridged supply voltages simplify cabling. And plug-in electronic modules offer improved service friendliness. Understandably, with integrated insertion protection due to the safety plug coding. The knife disconnection with integrated test points combined with the electrical interface saves space and cabling. Process interface, the ultimate cabling solution between computer and process.